Section 4.4 is about problem solving using systems of equations. On this first page here we have a list of strategies for or steps for the problem solving process. The first step may seem like the most obvious, but it's very important that when you read the problem, you read it and then reread it to make sure that you understand what's going on and that you define your variables. Defining your variables is going to be a very important step since we're going to have two unknowns and I need to know what x and y each mean. Okay? It's also very useful to draw a picture sometimes. Step 2 is about writing a system of equations. Step 3 is about solving it and interpreting the results. Again, I want to emphasize the importance of these first two steps. The goal in these problems is not actually to get the answer and to solve the system, but to write the system using our variables. So these two steps are the most important steps in this process. Look at an example. Alright, example 1, we have a rectangular lot whose perimeter is 320 feet and it's fenced along 3 sides. Okay, so I'm picturing right now my fence looking like this. Okay, maybe there's a building or something over here, I don't know, but there's 3 sides of fence. Now we've got an expensive fencing along the lot's length. So that's this one, we make it red. This is the expensive fencing. And then an inexpensive fencing along the 2 sides. Okay, so the expensive fencing costs $16 and the inexpensive fencing costs $5. That's what I got so far. The total cost of the fencing along the 3 sides comes to $2,140. What are the lot's dimensions? Okay, so I haven't defined my variables yet. I was just drawing a picture here to get an idea what's going on. But my variables are going to be, I don't know how long the sides or how long the length are. So we're going to say, maybe we can call those length and width. So my first variable is going to be W for the width. And there's 2 of those. And the second variable will be L for the length. And we're going to have fence just along one of those. So now it's time to write the equations. Alright, the 2 pieces that are going to hold this equation together are the fact that we were told that the perimeter of the lot is 320 feet, and even though there's only fence along all 3 sides, perimeter is a measurement of all 4 sides. So I know that the perimeter of a rectangle is 2 length plus 2 width. If it really had only one of the 3 sides, it couldn't have used that word perimeter. They might have said the distance around the fence was 320, for example. But that word perimeter is talking about the full figure. That's what the definition of perimeter means. Okay, so what we're having here is then 2 length plus 2 width equals the 320. That's the definition of perimeter for a rectangle. There's 2 lengths and 2 widths. Add up all the sides for the perimeter. Alright, so that was our first equation, and the next one's going to be about this total cost value, the 2,140. Okay, and the total cost, that's going to come in with the 3 sides here. We know that one of the legs, the length, costs $16. So it's $16 for the length, plus we know that there are 2 widths that cost $5 each. So 2 times $5 each for the widths. Now if you add that all up, it's going to give us the total of the 2,140. So I'm trying to kind of explain where these values are coming from and kind of talk through how I'd write this second equation. Okay, so these are my 2 equations here, and I can choose to use either substitution or elimination. Since I don't have any coefficients that are 1, I'm going to go ahead and use the elimination method or the addition method. What I'm actually going to do first is rewrite this equation just by multiplying the 2 and 5 together so that I see the coefficients are 16L plus 10W equals the 2,140. Okay. Now I want to think about this equation and what I need to multiply it by so that I can get something to eliminate. So let me write that equation down first. It was 2L plus 2W equals 320, and I'm going to need to multiply it by either a -8 if I wanted to get rid of the L's, or a -5 if I wanted to get rid of the tens. And let's just choose the smaller value here and multiply it by -5. Okay, so this equation is going to turn into -10L minus 10W equals, so let's take 320 times 5. That's -1600. Okay, so that is the rewritten perimeter equation. So we'll just copy down the 16L plus 10W equals 2140, so that we can add these two equations up. When I add them up, I get -10L plus 16L is 6L plus no W, those add to 0, equals, and then this is the same thing as 2140 minus 1600, so 540. And then we can divide by 6 to get that our L value is 90. Alright, now that I know the value of L, I also need to find the value of W. So let's do that. I'm going to use the top equation for perimeter since the numbers were smaller. So we'll do 2 times L, which is 90, plus 2 times W equals 320. 2 times 90 is 180, plus 2W equals 320. Subtract the 180 from both sides. 2W equals 320 minus 180 is 140. And if I divide both sides by 2, I get 70. And then again, the last step is just to interpret these results, put them back in terms of the original problem. So let me go back and look for my units and my length and my width. They're both going to be in feet. And we'll state our answer down here with the units. So the length of our fence is 90 feet, and that was the expensive side. Maybe it's a barbed wire on that side, I don't know. And the width is 70 feet, and that was the inexpensive side. And we've got our answers. Let's go ahead and look at the next problem then. In example 2, Rachel's taking a bag of dimes and quarters to a coin counting machine and opts to have the money converted to a gift card. If 113 cards are counted and the value of the gift card is $19.55, how many dimes and how many quarters did she deposit into the machine? Okay, so there are two types of quantities here, dimes and quarters, and those are going to be my two unknowns. I'm just going to use D for the number of dimes and Q for the number of quarters. Okay, so my two variables are D and Q, and I can determine that those are the two unknowns, the two variables I need, by reading the last line of the problem in the question. How many dimes, how many quarters, the two things I don't know are just going to be my two variables. Let's make an equation. Okay, now there are two equations we're going to make. The first one's going to be based off of the fact that there are 113 coins. So if there are 113 coins, that's just the pure sum of how many dimes and quarters there are. So dimes plus quarters equals 113. That looks like a 7. It's really supposed to be a 1. Okay, and the other equation is going to come from that value. Now, the problem doesn't specifically tell us how much a dime or a quarter is worth, but we know. So we're going to say a dime is worth 10 cents. So 10 cents for each dime, plus a quarter is worth 25 cents. So 25 cents for each quarter. It's going to give me that total of $19.55. Okay, so we have our two equations written. Since I used elimination last time, I'm going to go ahead and use substitution this time. So I'm going to go ahead and solve this equation for, say, Q. So if I have d plus q, it doesn't matter which one I'm solving for because both have coefficient 1. But if I solve for q, I'm going to be subtracting d from both sides, and I get that q is equal to 113 minus d. Okay. Now I'm going to take that value that q is equal to, and we're going to plug it into the other equation for q. So that second equation will become 0.10d plus 0.25q. In place of q, I'm going to put that 113 minus d equals the 1955. All right, let's distribute. 1.0d plus 0.25 times 113 is 28.25. 28.25 minus 0.25d equals 19.55. Keep solving. We're going to need to subtract the 28.25 from both sides. Okay. And combining like terms, 0.10d minus 0.25d is negative 0.15d equals, and here we have our 1955, not multiply, minus the 28.25, negative 8.7. And lastly, to finish that division, we're going to divide by negative 0.15, 58. So if I divide by negative 0.15 on both sides, I get d equals 58. Okay. I'm not ready for interpreting it. I spilled it into the box, but I need to go back up here and figure out how many quarters there are. Okay, so for quarters, I've got 113 minus the number of dimes, which we just found was 58. So the number of quarters is 113 minus 58, or 55. Okay, so my final answer, there were 58 dimes and 55 quarters.